always have these around like 7, 8 repeating but slightly changing lectures, and a new team introduced each year, which acts as this lecture series within the lecture series. And the idea behind that is to invite guests who share their different perspectives on territory, because we see territory as a polysemic concept that cannot be portrayed in one singular manner. So to have these multiple perspectives, and we looked in previous years, we started with my Zurich, following my nature, my earth, my species, and last year my energy. And the guests provided us their different lenses set within each team, with as a way to kind of have these different layers, different palimpsests of territory. And our agenda is, of course, a very socio-ecological and environmental one. And we have been also talking about these graded exercises, and we mentioned that we will introduce them with the guest lectures. So I wanted to also share some examples from before. So this is from the first installment of the lecture series, My Zurich, and this was done in collaboration with the cartographer Filip Rekačević as an experimental affective cartography, as a personal cartography of Zurich. And here you see from My Earth series our collaboration with Alexandra Ren, which was about these representations of Earth in the Anthropocene. So guests in that sense bring their modes of representation, their themes, and I can also show you this from My Species. It was a collaboration with Fei Fei Zhu. It was called Multi-Species Panorama, and she is one of the editors of Feral Atlas, and here the idea was to kind of have this scroll drawing, like a Chinese scroll depicting certain landscape transformations. And last but not least, this is from My Energy from last year, our collaboration with Gökse Günel, one of the guests, where we asked the students to have a look outside their window and imagine what they will see in 50 years from the lens of post-oil urbanism. And this was one of the examples. So in a way, when you look to all these examples, it also becomes about the pedagogy of the lecture series as a way to also destabilize this academic hierarchy, where we kind of also propose exercise and then grade you, but we involve our guests in all of these, all of the process as a way of multiplicity, which we think is very interesting. And you have been working on these sketches already. Now we will also do one of these exercises very soon, but this also creates a kind of this work on thinking about certain concepts, thinking about language. It creates maybe a shared vocabulary within this lecture series, a shared understanding and ethos of what we mean by territory, landscape, and design. And eventually what happens to all these sketches and graded exercises that you're working on, we ask you to bring in the original ones because we collect them and archive them in these book objects, which are produced at the end of each year, eventually, of course, with the intention to turn them into an exhibition. And they are at our chair. If you're interested, you could, of course, come and have a look. Finishing on that, I will now introduce you the concepts that actually Marco shared with us based on their work as studio folder. And as usual, you will have these 5 minutes to work on them and upload them on WhatsApp so we can have a look. So the first concept would be border. If you have checked the reading list, it was the introduction from their book, A Moving Border. So I guess it will resonate greatly with that. And the second term is infrastructure. And now your 5 minutes starts. Marco, would you also like to comment? You feel free. So we have infrastructure here as a grid in a more natural, let's say, shape. Border as the world, the planet, maybe. This is maybe more about the dynamic border, which Studio Folder is also talking about, that they are subject to change. And I think this dotted line kind of shows it really well, that it's nothing actually set. Okay, this is also about, I guess, the dynamic borders that are changing and having political repercussions. So we see again infrastructure as disconnecting grids and maybe also the energy grid within this urban scape. This is also something similar about the grid. So infrastructure is a lot of this between the grid. Mm-hmm. It's hard to see from here what is written, but I see roads and circulation, but it's from the human scale, I guess, going on to maybe planetary scale, we could say, urban scale. This border we can read maybe as a fence or picket line. So city made up of infrastructure, a wall, very nice as a border. Again, dividing two territories, maybe in a unnatural way, we could say. I cannot read this. Again, the energy grids, renewable energies, which we see in our landscape. This is maybe, it could be piping infrastructure, it could be transport infrastructure. Is also similar. So a natural border river.
Okay, I think maybe we can move on. Thank you for these wonderful examples. I will stop sharing this and go back to sharing the slides once again. Okay, so I will start with the introduction of the lecture and our guest, Marco. We are really delighted to have Marco here with us. In 2011, he co-founded Studio Folder together with Elisa Pasqual, who was also going to be here, but unfortunately, due to some work-related issues, she couldn't manage to come today. So Studio Folder is an interdisciplinary design practice based in Milan, quite close to us here, working both on commissions in the field of culture and the arts and on research projects examining the politics of visualization of spatial data. So together with Elisa Pasqual and Andrea Bagnato, Marco is the co-author of A Moving Border, Alpine Cartographies of Climate Change. Again, as I mentioned, this was part of your reading list. This is a book based on their long-term project, Italian Limes, and he has been also teaching methods and tools of representation at in Urbino at Istituto Superiore per le Industrie Artistiche between 2010 and 2022. And he also co-led the Architectural Design Studio 7, Something in the Air, at Royal College of Art in London between 2019 and 2022. I just, may I ask you something, Giacomo? This, I just don't see the, and I think I don't have, how do I scroll? Yeah, there's no mouse. Okay, great. Sorry. And he is currently Adjunct Assistant Professor at Columbia GSAPP and the head of MI Information Design at the Design Academy Eindhoven. And with the aim to question long-established narratives on the role of fieldwork, data collection and processing, and visualization methodologies, the work of Studio Folder tries to question their histories by interrogating the relationships between live data and the archive and exploring different modes of production of spatial knowledge. In his lecture, Marco Ferrari will introduce both research-based and commissioned projects by Studio Folder with a focus on the concept and realization behind some of the installations, image-making tools, and maps designed by the studio. We have been admirers of their work as our chair and also our colleagues, so we are really happy to have you here, Marco. Please join me here on stage.
Thank you. Perfect. Can you hear me okay? Good. Thank you, Nazli, for the invitation and this very kind introduction. Also on behalf of Elisa, who unfortunately couldn't be here today for like a work deadline. Also, thank you for this visual introduction kind of exercise at the beginning, which I think is it's not easy to think about these borders in infrastructure in this period, considering all the violence that are unleashing. So I'll start with a bit of introduction about the studio. So we're a small design and research practice based in Milan. Elisa and I started about 10 years ago. We're a group of architects, designers, and developers. And we often collaborate with a wider network of professionals and researchers, depending on the nature and complexity of the project we're working on. We define ourselves as an agency for visual design and spatial research, because these words contain much of the spectrum of what we do, stretching between the physical, digital, and printed environments to build either virtual or material displays that use this information as architecture. We're then focusing on one individual project today. I would like to present a reflection on the studio's work and my work also in a more of a pedagogical settings, and the role of cartography through a short overview of recent commission work, followed by a series of close-up views of 4 research-based projects. The various nature of these projects, for me, is still an unresolved tensions between different modes of work and doing research through design. So the visual design agency, we work on many different commission projects, often in the fields in different fields and with different media. But this kind of different project, from the editorial to the digital to the spatial exhibition aspects, really allowed us over the years to build a variety of skills. As an example, this is a publication we designed in 2019 that illustrates the 5 years of existence and activity of Atelier Luma, which is a workshop, research center, and designers residency in the south of France. For the publication, we designed a series of maps that highlight the environmental features of the Rhone River Delta and its wetlands, which constitute the territorial context of Atelier Luma. So we do a lot of kind of like this cartographic work for various editorial projects. One project that I would like to mention as well in this field is the magazine that we just finished to design, the first issue for the LUS, which is here at EH. It's going to be presented in a couple of weeks. Sometimes we design websites and digital platforms. This one here is a particular project we did a few years ago, where the design phase started not in the studio, but high up in the Alps, in the Dolomites, where we went to test one of Thomas Saraceno's flying sculpture, which is a hot air balloon, the black one you see here, able to rise in the sky using the heat from the sun and warm air trapped inside its envelopes. When we flew the sculpture, Saraceno, the artist, called them flying sculpture, we also attached a GPS sensor that we used to track the movement of it throughout the duration of the tether flights. This is like a long-term project by Saraceno that is using like this balloon to explore the atmosphere and advocating for kind of a switch from fossil fuels to clean energy. The website was a kind of a complex platform that at the same time simulated the flight of these balloons through real-time data, but also allowed for different forms of exploration, so wind data at different levels of the atmosphere. It was also conceived as a tool for exhibition for the artist, so the website could be transformed into an interactive exhibition installation. In many of these projects, kind of commission project, the agency of data has been explored in various forms and through various media, combining archival research, collaboration with experts, manufacturing, data visualization, filmmaking, exhibition making, and publishing. This is probably one of the most complex projects we've been working on. Was done in 2020 for an exhibition art test in Stockholm about Kiruna, which is a town in the north of Sweden with a long history of like iron mining, displacement of indigenous population, for which at the current moment the Swedish government is basically moving the town away from its original location in order to keep mining underground. So these are footage that was shot during this kind of architectural migrations of the original town to different sites. So for this project, we were asked to engage with an architectural object of sort. So the model you see on the right there, which was a model built in the 50s by a local municipality to discuss urban planning with the citizens. The model was brought to Stockholm and in the exhibition venue, and we basically scanned the model through photogrammetry and then built like a 30-minute data visualization video combining projections on the model and on the screen, telling stories about the environmental history and future of Kiruna and different aspects of its economy and population. So these are some examples of the videos. The video was organized into 5 chapters depending on scale. So with different kind of like set of information that were used to illustrate a sort of like introduction to the topic of the exhibition. This is a similar project, but very different in similar in terms of like approach, but different in terms of results. This was called The Value of Land, which is a collaborative project where we work with a group of like 10 different designers and researchers, developed within the framework of the 25th Biennial of Design in Ljubljana, in Slovenia. Our research looked at the Soča Valley, a historically charged area near the border of present Slovenia and Italy. The valley, which was also very famous in Italian history, was the theater of one of the most traumatic fights during the First World War, where many new technologies for the destructions of enemy lines were developed. But now this location is now being completely reconfigured to welcome tourism and sport activities. So it's kind of this kind of very charged past that's almost like disappear from the territory itself. The research we did tried to tie many different histories and narratives that crossed in this territory over the last 100 years, organized into three main threads. The first narrative was related to sound. World War I radically changed humanity's approach to sound, also often considered the loudest event in recorded history until then. With the advancement of firearms and the range of deployments, concealment behind and within the ground became a necessity, which in turn caused drastic visual impairment within the front line. To compensate, sound ranging was introduced in the battlefield, especially in the Alps, where the sight line between enemy lines could not be ensured. So sound ranging was a technology that was developed during, especially in these areas of the Alps during the battle, that was used to detect the triangulation of sound waves and the positions of enemies' artillery points. So operating in the mountainous landscape of the Soča Valley, where no accurate military maps existed, and sight was further obstructed by the terrain, phonotelemetry was a system for seeing where the eye could not see, transforming the land into a geometrical echo chamber. So we reconstructed the way in which, through documents from the army, where this technology was developed exactly in this area. It was the first time that the knowledge of topography and geology became paramount to military success. An Italian army reunited some of the most brilliant mathematics and physics professors and PhD students at the time, directing their attention to the battlefield. Applied science became incredibly intertwined with warfare. The second narrative, these are views of the exhibitions where all these different narratives were basically explained through objects and images and models, and a publication that could guide visitors through them. The second narrative was related to the transformation of the Office for Inventions, which was this group of PhD students that during the war operated as basically the scientists of the army, into what became afterwards the CNR of Italy, so the National Research Council of the country. So there was a kind of direct transition of the same people that work in the military to become the kind of like main scientists of the government. Where a series of young PhD students pioneered the modeling of natural ecosystem through a set of differential equations that determine the mathematical representation of nonlinear relationship between the populations of predator and prey. So the same people that work on sound ranging technology in the Alps were the ones that developed ideas about the evolution of ecology and species in the 30s and 40s. And finally, the third narrative is follow the work of a renowned artist performance group from the 60s, OHO, which in Slovenia was actively advocating for geomancy, which is an alternative perspective of the environment, landscape, and territory. Geomancy interprets the lay of the land as a repository of hidden energies within patterns of rock and soil. These beliefs have been rooted in the local communities of the Soča Valley long before modern religions took over. One of the founding members of this group, who worked in the valley, Marko Pogacnik, ended up designing the current flag of Slovenia after the War of Independence. So it's kind of like interesting to, during a year research, to encounter all these different narratives in the kind of very remote and almost peripheral areas of Europe. This is a different project, but more recent, that we completed last year. Was exhibition design and visual identity for an architectural photography exhibition. They were developed for different locations in Milan and Rome, as you can see here. The project came to us as a commission from the Italian Ministry of Culture, which right before the pandemic selected a group of young photographers to document a series of public and private buildings. representative of post-World War II Italian architecture across the country. Each of the 10 selected authors, coordinated by the curator and director of the Museum of Contemporary Photography in Milan, was assigned 25 buildings from different Italian regions and was asked to come up with an itinerary to connect each location. So our first move to design the exhibition was to collect all the data points of these individual travels, not just the photographs, but also the spatial data that allowed us to reconstruct the photographer's precise whereabouts, along with the transcriptions of personal and sometimes intimate notes, stories of their encounters with people along the way, and any sort of unplanned or unexpected situation they had to face while scouting for the architectural landscapes they were asked to document. So we kind of reconstruct like a detailed map of all of these voyages. So we wanted, for the exhibition, we wanted to understand how to give shape to this virtual territory. At the same time, one made with physical places, the architecture, of travel plans, of the artistic interpretation of the authors, of their memories and accidental encounters. In a way that could let the visitors of the exhibition retrace their way along these journeys. We also wanted to bend and stretch in a playful way the traditional format of architectural photography exhibitions, where usually individual images or mosaics are left floating on blank walls, in order to highlight both the dimension of discovery that is part of every journey and the collective voice of a generation of young photographers. So the main concept of the design consisted in the transformation of the entire volume of the exhibition room into an interactive cartographic space, translating the map into an architectural structure that can serve both as an index and a fictional landscape where the visitors can interact with the images while walking, weaving, and stepping into the installation. So moving from GIS to 3D software, we generated an elevated structure that resembled Italian topography to scale with 400 printed tiles sourced from a standard industrial flooring floor system. So the same ones that are used in like industrial buildings, airport, commercial malls. Each photographic print floats above the map, detached from the walls and supported by slender frames. The images become part of a spatial three-dimensional archive, replicating and amplifying the photographer's itineraries across the country. So these are like an image of the final show. So the visitors are left to roam besides, across and on top of the structure, to step onto the map and to find their own path through the work of the authors. The vertical frames are a support for the images, but also an architectural component that prevent people to fall or step into lower tiles accidentally. So sort of like ways of designing the way in the exhibition. There's some details. All of this was rented because it just used these industrial components. So there was basically no cost of manufacturing new pieces. And we kind of really like this idea of architectures and landscape presented as endless juxtapositions of elements and images. So where also the voices of the authors' individual perspectives are brought together in a collective assembly. These are some more images of the design. So the map was printed on these tiles, allowed to basically reconstruct a lot of information about the journeys of the photographers. From the top, the images almost disappear. So it's a very different view from the top and the bottom. Moving to our more research-based projects. The first one that I would like to introduce today is probably our oldest project in this sense. Started in 2014 as a participation of a architecture biennale back then, and they continued for a few years until we, after a few exhibitions and symposium, we produced a publication about it. The work took the form of a series of instruments, an interactive installation, and a publication. It started as an inquiry over what we saw as the apparent disappearance of European internal borders within the context of the new geopolitical landscape defined by the Schengen agreements and the climate crisis. I think this is still like a very pressing topic since I don't know if you follow the news, but like just yesterday, the Italian government announced that it's gonna close the border with Slovenia and basically suspend Schengen. The project has been, over these years, an attempt to unveil a problem of the representation of the border, the one between Italy and its neighboring countries across the Alps. There was undergoing a process of dissociation, while disappearing as a physical manifestation of the territory, with the removal of the architecture of checkpoints and customs. It still persisted as a representation on the map. So we started the work in the archives of the IGM, which stands for the Istituto Geografico Militare, which is the National Cartographic Institute of the country. Like in Switzerland, you have Swiss Topo, in Italy, you have IGM, which is still part of the army. So it's a kind of like half military, half civilian institution. So we started there in order to understand how the border was created in the first place. The photographs, the maps, the surveyor's diaries, documents and piles of notebooks full of handwritten geodesic calculation that we collected, indexed, digitized, are the record of how the first representations of the border came to be. This archival fieldwork has also been the opportunity to study the places, the tools, and the bureaucracies through which a state can craft a coherent cartographic and thus symbolical representation of its area and extents. All of this work in the archive was also not done before, because this archive was a military archive, so it was quite difficult to get access, and all of this material was basically never published in a kind of consistent way. By browsing through these materials, we realized that the production of the border was actually an architectural project on a very big territorial scale. In order to render a landscape into a cartographic surface, sensible through instrumentation, the mountains had to be physically altered. An architecture of augmentation had to be constructed onto it, as you can see in these images. The construction of the boundary line is literally a transformation of the landscape into an architecture for seeing itself, where issues of fidelity and calculation are related to the technologies that are used to perform this operation. So these images from like the early 20th century shows how, with very, very simple and subtle operations, like the constructions of these the little towers and the cut of like a siding line through the snow, the early geodesic measurements were done to connect different peaks and produce an accurate cartography of the Alps before aerial imagery, right? So these are all technologies used before. Even planes could take photographs from above, or of course satellites could map the terrain. By following this process of technological advancement, one through which the image of the border acquires more and more resolution, we found out a form of fiction in action. The entire landscape, with all of its natural features and topographical detail, had to be read as a canvas where the line of the border could emerge. The strokes, the hatches, the numbers and names contained in the documents of the border reveal this form of political fiction projected onto the landscape. The photographs and annotated images, like the ones in the scan, are the media where this operation is staged. So even like a seemingly simple document, like an image of like a glacier on high altitude, and the marking of the border reveals this operation on which the landscape itself is transformed to sustain the edge where you can trace the line. Before being built and materialized onto the terrain with physical marks, like boundary stones or metal plates, the border is the theatrical experience of reckoning, where the surveyors were at the same time operating the instruments of measure and being trained to see the border into the landscape. I think this image is particularly striking, where you see the surveyors, the instrument, the landscape, the line projected on it. This moment of observation is a recognition in real time of the feature of the landscape that are interpreted as a natural demarcation of the border. I put natural, of course, in quotation marks. This is particularly evident in the photographs, where you can see both the instruments of the survey and the surveyors. The same line passes through their eye and the eye of the instrument. Paradoxically, though, this process of alignment between lines and natural features becomes more problematic with every technological advancement in surveying and cartographic representation. The history along which the line of the border acquires better and better resolution, but its correlation with abstracted natural features gets fuzzier. So after some weeks in the archives, looking at this history of technology and border making, in conversation with the surveyors and cartographers of the state, we found evidence that a change in the natural environment was starting to threaten this symbiosis between the territory and its representation. The realization that the Alpine glaciers were melting so fast as to displace the watershed line and make it unrecognizable on the map, led the Italian state to come up with a new legal definition of the border. The concept of moving border, which is illustrated in these images here, was what the bureaucracy of the state came up with in order to justify the alignment between cartography and the melting of glaciers. So this is also like a document from the army where you can see two lines. The red dashed one is the one from the 20s when the border between Italy and Austria was initially traced, which is a very kind of smooth, almost imprecise lines, even if it's a line, so it's precise by definition. And then the second line, which is those dots, are the GPS measurements that were done in 2012, where with the high precision GPS tools, the surveyors traced the movement of the watershed line caused by the melting glacier. And then you see also the displacement of area between the two countries. So when we, after kind of this work of research for the exhibition in the Biennale, we decided that we wanted to show this movement of the watershed in real time. So we basically constructed a series of sensors, like this one is in this picture. They were designed to be placed on top of one of these glaciers across the border and detect their positions every hour and broadcast their coordinates to a remote server, and therefore determine like the shape of the glacier in real time. So we wanted to kind of reconstruct the idea of a glacier and therefore a border that can draw itself just through machinic augmentation without continued human mediation, like the one of the cartographers, for example, as a critique of a fascination of cartographers with objectivity and the consequent mechanizations of the eye that it produces. So these are images of the installation of the sensors. We went several times to these glaciers to test like different configuration, bringing like a different team of like different people with different skills, from scientists, journalists to architects and designers. And this is the layout of the grid. So we basically produced 25 of the sensors that I showed before, and we installed them as a grid. Just imagine that the border kind of crosses the grid in the middle. So the idea is that each point, which corresponds to a sensor, can be traced in 3D and therefore create a low resolution image of the surface across the border. So the sensors were designed also to stay there for 6 months throughout the spring and summer, basically. And they were solar powered, so they were completely autonomous. The interesting thing is that when the sensors started to broadcast their data, we realized that the process we activated was not only made of a physical infrastructure and machines, but was also relying on material and atmospheric conditions to operate, so the weather. Cloud cover and precipitation would degrade the quality of the signal of the sensors, the signal that were used to transmit their data. The latency of remote servers would sometimes delay the delivery of the new data. The humidity increase in the exhibition space will also affect the paper on which the machines penetrate the boundary line. So these sensors were connected to this robot, this kind of drawing machine, which could be operated manually or request of the visitors, and would trace every time a visitor of the show would activate it, a line based on the latest data received from the sensors. So basically producing a unique timestamp map of the border itself. The design of this machine was also inspired by sort of like the technological history of instrumentation that we studied at the museum of the IGM. So this, for example, these are the first machines that were used in the 20s to trace isometric lines and contour lines based on aerial data, which are basically drawing machines, but operated by manually. Or for example, model making as a representation of high altitude territories. These are also images from the archive where sections of the mountains were used to operate a manual CNC machine. Of course, nowadays, this process is very much different. Some territorial models are made through LiDAR or DSN data, DEM data, like this one. through which that we use to produce a model of the glacier that we mapped with the sensors. And that's the final configuration of the installation. A second project, which I'll be a bit more quick to go through, worked on, this was conceived for the architecture triennial in Oslo in 2016. We continued to work on it for a couple of years. It looked at similar concepts of the way in which the map is produced and atlases are produced, but on completely different scales. We also started to go from an archive, in this case, with the archival Landsat, the Landsat program, which I'm sure you're familiar with or you heard about. Landsat is a series of satellites that are still operating. I think now they just launched last year, Landsat 9. It's also the longest running satellite program for remote sensing. So basically for Earth observation from space, especially for environmental reasons. So Landsat started in 1972, program started by the American government. It still operates mainly from a headquarters in South Dakota, where we went. And also it's the place where they keep the archives of all the images ever basically produced by Landsat satellite. So they claim it's the biggest image archive in the world because over more than 50 years, Landsat produced, I think, more than 8 million images of the Earth. So Landsat is also a particularly significant program because it's still the kind of the body of images and the body of data through which current environmental imaging of the Earth is matched, is compared in order to see transformation at a regional scale. So for example, when you go to Google Earth, you compare data in a timeline, you're still loading Landsat data from, up to this, from the 70s. What we did for this project, though, was to try to visualize the archive of this data. The archive is completely open source. So if you go to the NASA or USGS website, you can download all the images for free. But we downloaded, we looked not at specific the imagery and the data itself, but the metadata of the images. So we downloaded more than 5 million images worth of metadata. So just the information that tells you when and where each of the shots was taken. So not the shot itself, not the image itself, but just the metadata. And with those data, we constructed this visualization. So this is like 45 years of density of images taken by Landsat. So wherever you see more white, it means that more images were taken in that particular area. And the interesting thing is that we realized that this image was not consistent, was not smooth and uniform. When you think about satellites and mapping from the sky, you think that this is like of course, when you look Google Earth, you see a very, very smooth single image, just a single representation of the planet. Instead, this single image was composed and put together in many different moments with the very different resolutions, with very different purposes and agendas. So we wanted to, when we realized this, we also noticed that in many cases, the density, like a high number of images in certain years, corresponded to areas of like a lot of geopolitical events were happening in that area. So for example, in the 80s, there were a lot of images from Russia and Ukraine, with the Chernobyl event in the 90s, with the Gulf War, in the Middle East, in China as well. So we wanted to kind of like show the displacement of the density of these images over the map over the course of the last 50 years, basically. So we set to design an installation which worked with transform this digital data into the physical representation of the globe. And again, working with drawing machines, we basically broke down the data into year-by-year data sets. And we wrote all these single-year data sets into globes, ending up having so these kind of representations in which for every year we could only see where specific images of Landsat would basically be focused. The installation was a bit of a combination of different models and what we call like research props. So objects that could show through different perspectives the idea of the fragmentation of the atlas. So the idea that the kind of very smooth and very easy to access map that you have on Google Earth is instead the not a combination of a lot of different informations. The next project, which is still ongoing, started during the pandemic. It's a research that is focused on the archive and legacy of Buckminster Fuller. So far, it's been presented into 2 exhibitions in Madrid and Shanghai, to which we couldn't go because they were all happened during the pandemic, so there was like travel restrictions. But we're working on a website right now where the findings of the research will be published. So as I was trying to resolve modern faith in transparency, scientific progress, computation, cybernetics, and information management, during the course of his long career, Fuller developed a series of visionary projects that anticipated the impact of many contemporary technologies and almost prophesized the conditions of our algorithmic regulated existence. The name we gave to the project, Everything We Know, is inspired by the title of a series of lectures that span 42 hours, which you can find on YouTube, and that present all of Fuller's major inventions and discoveries. The original title is Everything I Know. The topic in the lecture ranges from the Maxion house from 1927, the Maxion car and the Maxion map, to the geodesic domes, the tensacity structures, as well as his theories on synergetics. Our work in installation combines the 4 cornerstones of Fuller works: the Maxion map, the war resource inventory, the geoscope, and a war game. In particular, the latter one, the war game, we saw it as the outcome of a series of interconnected researches of Fuller's lifelong quest for planetary scale awareness through computation. The Maxion map that you can see in this, sorry, the caption is wrong, that you can see in these pages from Fortune magazine. The Maxion map, which Fuller patented in the 50s, and it was the starting point of our research, is a projection that aims to introduce a representation of the entire globe under a new perspective, one not organized around the hierarchy of latitude of north versus south. It is a cartographic projections that can be held and explored through manipulation, constantly reconfigured in order to provide alternative views of land masses and oceans, and of any information that can be projected onto them. So there was a completely new form of like cartographic projection that mostly responding to traditional Mercator representation of the globe. The second of Fuller's inventions that we looked at is the geoscope. Here in this image is a prototype that he assembled with students of Cornell universities in the 60s, and it shows a semi-transparent globe showing geopolitical and geophysical informations, alongside a range of climatic, geographical, and sociological data that were to be shown through light bulbs appearing as illuminated and pulsating pixels. So the map, the globe itself, was a canvas for single point data to be displayed on it. According to Fuller himself, the geoscope was created in order to facilitate the visual communication of invisible information, patterns, to humanity in a timely manner, visualizing all sorts of global long-term trends, everything from continental drift to human migration to use of transportation. So sort of like a global data set of everything that could be mapped. Fuller's dream was to create a large-scale version of the geoscope in front of the United Nations building in Manhattan, to be installed on a tiny rock called the Blackwall Ledges, situated a quarter of a mile south of Roosevelt Island on the East River. The plan was for the geoscope to be connected to computers, which would allow it to display both historical and live data sourced from a centralized database, and enable politicians behind the transparent facade of the UN building to see the distributions of global resources in real time. So a deeply political project of the use of information to basically instigate kind of global political awareness. In the words of Fuller, and I quote, "Few other vital challenges are apprehended in time by human brains. When humans cannot see something approaching to destroy them, did not get out of the way. Question: is another an instrument that can inform humanity about its invisibly trending evolutionary challenges and do so in time to allow them to satisfactorily anticipate and cope with inexorable events? Yes, that is the geoscope, which can be swiftly realized both physically and metaphysically. End of quote. So it was kind of a utopian project of bringing information to its widest kind of range and agenda possible. The final work by Fuller that we looked at was the war game, which is a bit of a mix between the Dymaxion map and the geoscope. The war game was developed over the years with different students from different universities, for which Fuller managed to put together a centralized database that he envisioned could be then the source of all the information for the geoscope prototype. So the war game was both like a workshop simulation, but also an attempt to really collect and put together all this data for this utopian project he had. All the information that Fuller and his collaborators collected that was stored in translucent data sheets, which he called the war resource inventory, where any sort of content was translated into matrices of dots and lines, a unified, universal, and simplified language that would allow to compare a wide array of different topics and materials as abstract particles and standard quantities. So everything from like movement to resources to infrastructure was flattened and represented in a kind of very, very simple abstract way. These data sheets were used as input for a series of workshops that played over a theatrical, oversized version of the Dymaxion map, and where for several hours in a row, participants could debate global economic and political scenarios by literally walking, sitting, and lying over the world. So the project we were commissioned to do was basically a reenactment of like these histories. But also we conceived it as an attempt to move a critique of Fuller intention, or at least their legacy and interpretation in relation to contemporary techno-optimism and today's over-reliance on computation, management theories, and the larger availability of real-time data to make sense of the world. So we consider today is not Fuller's dream of having like real-time information always available through the internet is basically came to be. But on the other hand, this idea that this could drive a sort of global justice never really happened. So we spent months collecting and indexing the largest possible amount of open source data sets about a large spectrum of topics, ranging from any sort of environmental data, like sea surface temperature or global forest loss, to statistics on IKEA stores, nuclear power plants, drone strikes, etc. Considering the internet as a contemporary distributed version of Fuller's war resource inventory, we assemble a real-time portrait of the planet through data. So we make this kind of effort of really collecting everything possible sourceable on the internet. We then wrote a series of scripts that edited all these various data sets through a customized workflow and transformed them into dot maps, where every particle would represent a standard unit. This operation was the basis for us of a critique of data visualization, where it comes to the creation of homogeneous view of the words through a unique unifying lens in order to produce an illusion of control and abstraction. So we did the kind of this, not exactly through computation, through automation, what over the years, Fuller students basically did manually to produce the sheets that you saw before. The same dot maps were then projected onto the Dymaxion map, which was not easy. This was probably one of the most difficult parts of the project because the mathematical formula of the Dymaxion projection is still protected by copyright of the Fuller's Foundation. So you can really find, for example, in GIS software, this projection. And therefore, we had to kind of come up with scripts to be able to move from a Mercator projection to a Dymaxion one. Once all of the data were unified, we developed a digital sandbox where they could be animated and compared with one another. Not really seeable in this projection, but basically all of this data were unified and therefore could be projected as thousands of particles into the map. So this endless carousel of information was very diverse in topic and themes and subject. reveals serendipitous and random associations, allowing the users and the visitors to the exhibition to follow their own curiosity in exploring the hundreds of data sets uploaded in the backend. So this is the final view of the installation. Again, these are images that were sent to us, so they're not really legible, but this was like a huge kind of 5-meter long dimension map where it was an interactive way of looking and seeing these like 500 data sets through these kind of particle views. We also designed an interface, almost ChatGPT style of interface before ChatGPT, so with different technologies, where you could chat with a series of fictional characters that could basically allow you to interact with the data and pull out the map a different set of data sets. These are images of the interface. Yeah, this image is mostly black, so you can really see it here. Yeah. So we're now working on the translation of all this work into digital and web form. The last project is very different from the previous one. It's also probably the one that mostly connects to the topic of the series. This project has been developed and is being developed not within the studio settings, but within more academic settings, and in collaboration with two of my teaching peers and colleagues, where I've been teaching a 3-year-long studio at the Royal College of Arts in London. So Elise Hanchok and Jingru Sen Cheng. The project is a long-term research on what is called the Sky River, which is a large-scale geoengineering project that is being developed by the Chinese government on the Tibetan Plateau since a few years now. The project has been so far published on the Avery Review, where you can read a long-form essays on it, in the form of a short film that we produced for the Critical Zone exhibition created by Bruno Latour and Peter Weibel at ZKM Karlsruhe a few years ago. We're currently working on the publication of this project. This is also based on remote research, so we haven't had the chance yet to travel to the places that we're describing the project for a variety of reasons, but mostly because of the pandemic, and also because it's very difficult to get access to the sites in China. So this composite image of the Earth and in its atmosphere brings together water vapor and particles. So these are 2 layers of the map that you can see here. So particles like dust, soot, mold, and bacteria, which are 2 fundamental components of what we are going to observe in the following slides. This full disk visualization is centered above China, and the image itself is derived from Fengyun 4 satellite data. Fengyun, which means winds and clouds, are the latest series of China Meteorological Administration's geostationary meteorological satellites. In this other image, which is from NASA from 2008, you can see a dust storm traveling westward from the Mongolian plains. And we can see in this image the evidence of a phenomenon on the rise. According to historical accounts and weather data from AD 300 to 1949, China experienced a dust storm on average every 30 years. After 1990, the dust storm occurred almost every year. The causes of this dramatic increase in such storms is partly because of deforestation and a huge increase of water usage, both for agriculture and industrial development in the country. In the words of the NASA scientists that elaborated the data to compose this image, and I quote, "The deep tan dust is not only thick enough to completely hide much of the land surface below, but it almost forms its own topography, with reaches of dust rising up below the clouds." End of quote. And also in the words by anthropologist Jerry Zhe, who wrote an amazing book published last year about Chinese political intersections between statecraft, landscape, atmosphere, and society. And I would like to read this this quote that comments on the same image. The sky was full. There were mountains in it. Lofted into the atmospheric foreground, the storm is a continent in dust, rising and falling with the surge of the spring winds. Pictured in multiple simultaneous phases of a geometeorological process, China is both the territory and its uncanny meteorological double, and the shifts in terrestrial phase between them. This China rises and falls. Its earth is a plume, unfurling with the coming of the spring. The continent had become a constituent sky of our own manufacture, unfolding the brittle line between nature and culture into a vertiginous interface of socio-natural entanglements. Atmospheric rivers are not a new concept, and are currently considered extreme weather events. You might have heard in the past winter the effects of the atmospheric river on the coast of California, where they discharge like exceptional rain and precipitation. And in particular, the most studied examples of this phenomenon is the Pineapple Express, which is a weird name for an atmospheric river that originates near Hawaii and flows eastward as it follows the global ocean conveyor belt. A long recorded history of observations has linked winter storms along the coast of the western United States and Canada to this phenomenon, to the extent that an array of atmospheric river observatories have been installed between Southern California and the Canadian border as an early warning systems to predict the landfall of atmospheric rivers. So these are images from of these observatories that have been installed in those points you see over there. But when these atmospheric rivers were discovered, so in 1992, a group of scientists from MIT and NASA proposed naming what they observed as filaments in the atmosphere, tropospheric river, as they had the characteristics of the rivers that we know on land. Places where water gathers to move in lengths many times their width and persist for many days while being translated through the atmosphere. So by looking through different instruments, the atmosphere, they realized there was concentration of water vapor. They were very stable and recurring like very often in the same places. And they look like rivers in the visualizations. So these are the ways in which they measure these. The interesting thing is that they produced these images and they discovered atmospheric rivers while they were looking for carbon emissions. So they were trying to see the origins of and the distributions of carbons in the atmosphere. And they realized that carbon was carried by water vapor. So they were able to detect atmospheric rivers and discover atmospheric rivers by looking at carbon dioxide concentration in the atmosphere. So during this research, Newell and Zhu, the two scientists that work on this research, were able to determine that these filamentary structures are in fact responsible for the transport of almost all of the water vapor in the atmosphere. Despite discharging only on average a third of the water they carry as either rain or snowfall. So most of the vapor that the atmospheric river carry in the atmosphere remains there. Atmospheric rivers, vectors, which originate in the tropical and subtropical regions and travel polewards, represent such frequent features of global atmospheric circulation that evidence of their presence can be observed in ice cores from Greenland and Antarctica. So it's a very kind of historical phenomenon. So within this history and research, the current conceptual framework of water resources is largely limited only to water in rivers, lakes, underground aquifers, and other sources that can be used by humans directly, and does not normally include water that evaporates from the land surface and transpires from vegetation. We can observe in this classical representation of the water cycles from the 30s, conceived and drawn by Robert Holton, an American hydrologist and civil engineer, who established what is considered the modern Western understanding of the water cycle, how a particular idea of water behavior is modeled after northern temperate climate within a society oriented in the exploitation of natural resources for a state-led industrial development. These historical and geographical circumstances were basically the foundation of the hydrological science were born, and the ones in which this diagram was created do not correspond to the experience of water in for most of the world population. Nevertheless, categories as green or blue water persist in contemporary hydrology, and we find them also in some recent papers of a group of scientists and engineers from Tsinghua University in Beijing. These different forms of water resources all exist and come into relation with each other in the critical zone. The heterogeneous near-surface environment in which complex interactions involving rock, soil, water, air, and living organisms regulate the natural habitat and determine the availability of life-sustaining resources. So what this video excerpt shows is that this Chinese scientists that work on atmospheric rivers and sky rivers invented a new category of water, which they call white water, which was defined as the potential precipitation from sky river that could be used for like as a human resource. The papers that they wrote, published between 2018 and 2019, define particular bodies and duration of tropospheric river filaments as sky rivers. So not atmospheric rivers, but sky rivers. So while atmospheric rivers in traditional hydrological science describe a phenomenon that physically exists, the sky river is a kind of calculation, a constructed model, explicitly devised for new forms of visualization and instructions on atmospheric water resources, the facilitation of its management, and potentially the establishment of claims of state ownership. So the difference between these two researchers is that atmospheric rivers are just visualized as kind of like existing feature of the atmosphere, while sky rivers are infrastructural. Basically, it's an infrastructural project. It's a way of tapping into this quantity of vapor and discharging through a weather enhancement technology. So the study of the sky river, these Chinese scientists argue, requires the establishment of a new discipline, one that develops theories and methods of expressing atmosphere surface water resources that can meet the multi-time scale process of a surface runoff. It is this process of precipitation and evaporation, the discontinuities, topologies you see in these maps, where those who studied and named the sky river believes that this new and critical possibility can be found. So you see that also like these images compared to the one from the 70s from the American scientists are very different. So instead of representing fields of forces, they represent precise vectors and paths. So the sky river, besides being a theory, is also like a test project. So basically is a testing site on the Tibetan Plateau, where these scientists, for what we could find, started to find technological ways to extract water from the monsoon sky rivers that traversing the border from India to China. So the total incoming atmospheric water vapor of China is estimated to be close to 20 trillion cubic meters per year, which is more than 4 times what falls on China as precipitation. So there's a huge potential of tapping into these reserves and making it rain. And these maps, which again produced by the scientists, show the distribution of water vapor, the so-called white water precipitation efficiency above the Tibetan Plateau. While previous research on atmospheric rivers has been focused on the transportation of water vapor and its short-term manifestation in extreme weather events, the attention of the Chinese scientists is on the long-term configuration infrastructure of atmospheric rivers so they can be fully brought into the water resource management systems. So basically to move from these maps, this kind of scientific detection, satellite detections of water vapor into water that can be actually used for agriculture and industry. So what we found is that as part of this testing site and as part of this long-term sky river project, the Chinese scientists proposed the use of a series of like machines like these ones, which are cloud seeding stoves, so ground-based small-scale infrastructure that have been used for decades to control precipitation at the regional scale, so basically enhance precipitation for agriculture. But deploying like thousands of them across the Tibetan Plateau and synchronizing them through satellites in order to be activated whenever enough concentration of water vapor would pass over the mountains. So these stoves started to be installed on mountaintops in strategic positions where they would be exposed to upward winds that they can carry their exhaust of the combustions into the cloud formation above and trigger rain. So these are all images that we score from like different sources online where they show different models of these stoves, but also you can see they're all kind of industrial produced and very similar. So the outside is almost kind of decorated with writings and simple decorative elements, but inside they contain military rocket technologies that is basically a silver iodide generator. So they're used to combust and burn silver iodides and release their gas exhaust into the sky. It's a cloud seeder, basically. By 2019, more than 500 stoves, solar power, so isolated, remotely controlled, with the capability to be operated through a satellite forecasting system, were installed on the Alpine slopes of Tibet and other areas for experimental use. So the Sky River project is not just a scientific theory or study, but it's also a ground network of tens of thousands of these stoves, making it the world's largest and most ambitious cloud seeding project and experiment to date. So these are diagrams that show the kind of integration between these technologies and the way in which these stoves operate with the different arrays of machines and other communication and synchronization infrastructure. But also what our research focused on is the kind of long-term history of this technology. So sky rivers, we found, emerged from a history of water management that dates back thousands of years to the establishment of the Shia dynasty. And the flood-based recreation myth, wherein the founding king of the dynasty, who's known as Yu the Great, established the proper order of the mountains and the waters by opening passages in the mountains and guiding rivers into their courses. The cloud logo of the CMA, the Chinese Meteorological Administration, which is, we can find on almost all of the exteriors of the stove, carry forward the language of the Dunhuang Star Atlas of the 8th century. A historian of ancient China, Mark Lewis, writes too that it is not a coincidence that the root of the Chinese character to govern is water. The very lines of the mountains and rivers that you traced out are those that divided China into 9 provinces. So also similar to the way in which the Western tradition borders are defined by watershed lines. So this story of like using water and a river to administer and divide territory is a story of war making. And so it's also a story of infrastructure. According to Mark Lewis and others, this history offers a mythology of contemporary practices of water control in both its literal and figurative use, of demarcation, division, expulsion, to achieve the desired hydraulic stability of the Yellow River and flood control in North China Plain. So these are images from like a scroll from the 18th century that show kind of water management technologies and territorial planning for the Yellow River.
敢想敢干的邻县人民遵照毛主席“水利是农业的命脉”的教导。
Sorry, it was meant to be audio. So this is a video from the 70s. Sorry, the modern geographical imagery of China is tethered to a rigid conception of water balance, where a scarcely populated, water-rich south is often placed in opposition to a densely inhabited and agricultural developed but water-scarce north. So from like decades ago, this is like large-scale infrastructural projects were designed and constructed to bring water from the south to the north. China today, as many other countries, is facing increasingly severe water scarcity due to uneven spatial distributions of water resources across the 9 major river basins of the country. These disparities are reinforced by spatio-temporal patterns of precipitation and also exacerbated by mismatch between local socioeconomic needs for water. The result is that there is a limited overall amount of water resources with extremely low water availability in many areas to the north of the Yellow River, which we see here in a map of water stress indexes. Not really clear because it's mostly black again. So while the majority of China's irrigated farmland is in the north, and also a lot of its cities are on the east coast, its products mostly feed the heavily populated cities of the south, where wealthier dietary preferences demand water-intensive crops, alongside a spiking increase in meat consumption. As water moves northward through rivers, pushed through aqueducts and canals, pumped from aquifers to irrigate exhausted northern farmlands, threatened by desertification, it also circles back south inside food. So we kind of like really interesting to, again, map this cartography of water, not just through the visible water, but also the way in which water moves around the country and its economy inside its products, so food and meat. So water flows in the atmosphere above and below the ground, but also through economies. So the river, the Yellow River in particular, is not just a single stream, but many streams that flow through bodies, territories, and data centers. So this is a map we built with our students, showing the evolution of this large-scale infrastructural project, which is, I'm sure you've heard about it, because it's been like in the making for many, many decades, with the aim of transferring through different river basins, water from the Yangtze to the Yellow River. So from the south to the north, along different routes. So the Sky River the idea of the Sky River project is to enhance the south-north water transfer project to overcome its limitation, because still nowadays, despite all of this kind of infrastructural work, the demand of water from the north is not enough. So the Sky River project is a paradigmatic act of geographical reimagination. In its conceptual leap, atmospheric water and conventional surface water are brought together in a long-term coupling that follows the way water gathers and flows in terrestrial rivers. In establishing a new theoretical framework for the hydrological cycle, there is a simultaneous expansion of the domain of resource extractions in the atmosphere. So if the topology of water is imagined as a continuous surface, water flows into the plateau from sky rivers and out of the plateau through rivers on the ground. Water vapor is not a stable feature of planetary origin, but of the atmosphere. Its fundamental compositions and materiality challenge us to overcome our familiar principle of direct Cartesian verticality when conceptualizing borders and boundaries. Projecting the topology of the watershed up into the sky with wind, temperature, and pressure as vectors, a vertical appropriation takes hold, and principles of terrestrial sovereignty are extended up and into the atmosphere. New lines on the land are drawn by changing the geography of the sky in the form of displaced rainfall, fortified glaciers, floods, or chemical alteration of the water-bearing stratum above. Faced with a new concept of atmospheric water resources and a new definition of the water that circulates in the atmosphere, water vapor is converted from a natural occurrence into an asset that can be secured through state infrastructure. This research will continue examining how established and emerging, successful or not, plans to govern waters, including large-scale water modification proposals such as the Sky River, where water vapor is seen as to act like a river itself, extend the fantasy of control of the cartographic imaginary and concept of land sovereignty up and into the domain of the atmosphere. Thank you.
Thank you, Marco, for this wonderful lecture. It was actually amazing to see the variety of work that is embodied within your work. Also like the technology, the skills, techniques, and it makes me wonder, I have a very quick question about how studio folder is also structured. I mean, to kind of also produce such work. Who do you work with? Is this also your office kind of transdisciplinary? Do you have different constellations for each project? This is what I was thinking
absolutely.
about.
In fact, it's a very small studio in the end. So it's me and Elisa, and we have a couple of like long-term collaborator. We're not strictly part of the studio on a kind of daily basis. Another architect, Pietro Leoni, who worked on most of the technology of the installations, and Angelo Semeraro, who is an amazing computer scientist and developer, works more on digital infrastructure. And then at the studio, we have like a varied group of mix of designers and architects. Usually the size of the studio is between 6 or 7 people, including me and Elisa, so it's quite small. And then depending on the research, we of course collaborate with the scientists or specialists from different disciplines. For the last project, the Sky River, again, was not a studio project, so was developed initially as a brief for the architectural design studio at the Royal College by me, Elise, and Cyan. And then only some of the material I showed today were developed in the first part of the year with the students. So the video excerpts were this kind of data visualization narrative that were done by the students.
It's crazy. It makes me feel like I mean, we are obviously like that, but within a climate fiction novel.
Yeah,
this
totally.
weather monitoring device, modification device. Yeah, it's very interesting. I'm sure some of you have questions, but I will leave that to the end because whoever has to go for maybe another lesson could leave, and I will introduce the graded exercise first, and then maybe we can have a few minutes after that. Thank you very much. So, okay, so back to our team. As I mentioned, and as you all know, this year's theme is My Weather, which our intention is to trace uneven impacts of environmental crisis on the ground and reflect on the entanglements of weather, atmosphere, climate with the constructed environments and ecologies. So today we started with the first guest lecture, Marco Ferrari of Studio Folder, and now I will go on to introduce the first exercise. So the title is My Blank City Boundary, a personal cartography, which is of course inspired by the work of Studio Folder. So you have seen Studio Folder questions the stability of administrative and natural borders. And in the midst of climate crisis, they even call into question the possibility of a natural border that does not change. Marco was also showing the watershed line on the Alps. It is actually, we can see it as the epitome of observing how volatile these physical benchmarks are. And what they also propose in this project is instead of a static border, they propose a dynamic one. So for this exercise, we were thinking that we can go into details of the concept of border and take our city of Zurich for this. So observe the borders of Stadt Zurich, the administrative borders. So everyone in the class will be assigned to a particular kreis bordering the city. So not the inner ones, but on the city's borders, administrative borders. So you will receive this map, which has these exact borders, and you will receive the information of which kreis that you will be working on. I will share this with you. So let's say if your name is assigned to kreis 3, you will be working on this space within the green rectangle, which borders, you know, not the borders between the kreis, but the city. And let's say sometimes you and the idea is that we will ask you to make a 500-meter walk on this exact border, the line which you're seeing. And within this walk, maybe sometimes you will walk in these really material, physical borders that are indicators of the borders, like topographical indicators, like rivers or mountains, etc. Let's say again on this kreis, if you look the kreis 3, district 3, then you might be walking on the ridge of Uetliberg, and you would be seeing that kind of elevation on changing of elevation on both sides. Sometimes you might be walking where the indicators might not be so apparent, but you would still be able to find these little signs put there by the Stadt. You would see like it says Grenzen. You might observe those, and sometimes it might just be invisible. And on this walk, we will ask you to take 6 photographs. So every 100 meters, starting with the point 0, facing on the direction that you're going and taken from the ground. And at the end, you will also receive this template, and we will ask you to hand in a map with these 6 images and caption describing your walk. So on this left side, you will have the map. And here on the gray, smaller part, you will put like a position map where we can see the exact position where you walked. And you will also on the map indicate, as you see on these numbers, like from 1 to 6, the position where you actually took these photographs. And for the map, your drawing could be hand-drawn or digital. It is up to you. Flat or perspectival, this is also up to you, based on the type of message that you want to convey with these maps. And you're also, we would ask you to use either a cadastral map or GIS as a base. So we would have this kind of geographic accuracy of the actual path that you walked and the border itself. And these 6 photographs that you take during the walk as horizontal images, not vertical ones. Yeah. So here I put also one inspiration from a work called Ben Nevis Hitchhike by walking artist Richard Long, where he actually literally hitchhiked in April 1967. He walked and hitchhiked from London to the summit of Ben Nevis, which is a mountain in Scotland, and back. And this journey took him 6 days. And he had this kind of method where each day at 11 a.m. he took a photograph. One was, he was pointing the camera straight up, one straight down. And this is all the photographs that he took during this journey. And here, this is how he represents it with also the map that he took. And we will also then ask you to fill in this blank with your own words based on what your boundary, city boundary, what your observations, findings were about. So this is it. I will send you an email about this with also the documents and the template. And if you have any questions, you can ask now after the lesson or send an email. And these are the readings from today. You might also want to go back to them again to kind of think about this. And this is for the next session, which will be after the seminar week on November the 2nd. Thanks everyone for listening.